Hello everybody, in this lecture we will study cocoa and chocolate technology. The various aspects of cocoa bean, cocoa pod, then post harvest treatment of cocoa, processing of cocoa, chocolates and its type, and chocolate manufacturing technology. These topics or these subtopics will be covered in today's lecture. So, let us see cocoa, what cocoa is. Its botanical name is Theobroma cocoa. So, you can see the cocoa pod in this tree, it is a long tree, okay, like jackfruit etc. This cocoa flowers and then which is further converted into pods, and they are on the main trunk or either on the main branches. These parts are born on the tree. So, the cocoa is actually the dried and partially fermented fatty seed of the cacao tree from which the chocolate is made. So, in this pod inside there are about 20 to 50 beans arranged in a thick leathery rind inside that pod. So, these seeds which are there inside, they are embedded in white or pinkish pulp, and the seeds are the principal source of cocoa or cocoa powder, which are highly prized as a nutritious beverage, and chocolate they are used as food all world over. The principal varieties of the Theobroma cocoa are Frosto from the Amazons regions and grown mainly in West Africa and bulk cocoa. Criollo, it is rarely grown because of the disease susceptibility. Trinitario is a hybrid of Forastero and Criollo, and Naconolal with the fine flavor, it grows in Ecuador. The post harvest treatment of cocoa, that is raw cocoa beans have an astringent unpleasant taste, and they have to be taken through the various post harvest treatments of the fermentation, drying and roasting to attain the characteristic cocoa taste, color and flavor. It is like similar to that of the coffee beans we earlier in the last class we discussed, we studied. So, here also these cocoa beans or seeds, they have unpleasant taste. Okay. So, the various post harvest treatments are done to cocoa in order to develop the characteristic color and flavor. So, that is the major post harvest operations and treatment of the cocoa pods are: number 1, first the gathering the cocoa pod, then the pod storage as a mean of pulp preconditioning, opening or pod breaking, then fermentation of the beans, drying of the fermented beans, storing, packing and sorting, packing and storage. So, these are the post harvest treatment of the cocoa bean pod and obtaining the beans from the cocoa. So, the mature pods are removed from the tree by machete or by a similar knife attached to a long pole for the higher branches, gathered and stored for further processing. Post harvest pod storage as a method of pulp preconditioning involves keeping the harvested pod, that is the fruit which you have seen in the last slide in the figure, that is it is kept for a period of time before being broken. Okay. The pulp preconditioning entails changing the properties of the pulp of the cocoa beans prior to fermentation. Because the pulp is the substrate metabolized during fermentation, changes in the pulp affect the production of acid by lactic acid bacteria, yeast or even acetic acid bacteria. The main objective of pulp preconditioning is to reduce the formation of acid throughout the course and subsequent fermentation without enhancing the degradation of acid at the end of the fermentation process. Then after that the cocoa parts are opened and they are depulped, that is after a day or two the parts are split open with the help of machete, and the beans are and pulps are removed either by hand or by hand implements or even mechanical depulping equipment. Okay. The cocoa fermentation, that is the beans which are obtained, they are next subjected to the fermentation, and this fermentation aids the degradation of the bulk of the pulp surrounding the cocoa bean, so that the bean can easily be dried. The process of fermentation induces biochemical transformations within the bean that lead to the formation of color, aroma and flavor precursor of the chocolate, not actual compound, but their precursors are developed. Without fermentation, cocoa beans are excessively bitter and they will be astringent in taste. So, different types of fermentations are used. Okay, that is heap fermentation. You can see in the pictures, that is the cocoa beans are just collected in a heap and they are covered with banana and other leaves, and then heat inside respiration, it facilitates the fermentation. Okay. Then box fermentation, in the shade they are kept in the cover in a box, they are basket fermentation or tray fermentation. So, different types of the fermentation. It is basically storing, keeping these beans or parts for some time. Okay. Maybe depending upon the weather conditions and time during the cocoa season, period of the growing season, it may take about 3 to 8 days for the completion of the fermentation process. Okay. You see that during the fermentation process, as I told you, that is in figure, they have seen the various volatile acids, sugars, alcohols, etc. they are produced in the beans, okay, and which act as a precursor of the flavoring and coloring compounds. Okay. Then after the following the fermentation, next important operation is the drying. Okay. And here they are said either by shade drying, all right, or in that is a open environment solar drying and pashmere. These are spread, okay, that on some sort of raised platform, as you can see here in the figure, and the moisture content of the bean is reduced to a level of 5 to 8%, because this is considered to be the appropriate level for the secure storage of cocoa for a couple of months prior to marketing and processing. If the moisture content is above 8%, there will be the risk of mold development within the beans. Moisture content below 5%, the beans will become very brittle. So, 5 to 8% is the average moisture content. The drying of the bean continues the chemical changes that occur during fermentation, and it improves the flavor development. Okay. It reduces the bitterness and astringency, and it develops the chocolate brown color as well as in the well fermented cocoa beans is obtained. Okay. So, dried cocoa beans after fermentation, you see that from the pod side, these are the rows. Then comes the processing of cocoa, that is technology for cocoa processing. That is the beans are taken, they are cleaned, then broken and winnowing. So, after winnowing, that hulls are blown away, then the inside that the nibs or cotyledons are obtained. These cotyledons, which are valuable or prized sources of the chocolate or cocoa powder, all right, they may be directly sterilized, roasted, okay, and or they may be subjected to alkalization treatment or Dutching process, then followed by roasted. After the roasting, that is the nib is ground and liquor production, and this is the in the trade is known as chocolate liquor or bitter chocolate, and then this chocolate liquor is further processed or pressed. It the cocoa butter is obtained and the cocoa cake, that is pressed cake, and this cake is further pulverized into fine powder, which is used for making beverage. So, you can see here these are the two major products after processing of the cocoa bean. One is the cocoa butter, okay, which is very valuable ingredient in various confectionery, ice cream and other products. I will tell little later about its characteristics, and then cocoa powder, which is a prized item for making various beverages. This is used for beverage making. Then the quality of cocoa beans is an important trade parameter because the quality of chocolate depends to a large extent upon the quality of the cocoa beans used to make the chocolate. So, the bean selection and quality criteria may vary depending upon the local conditions, but in general the degree of fermentation, the moisture content, as I told you, maximum may be 7.5 to 8%, number of defects and broken beans, beans count that is in per 100 gram how many beans are there, degree of moldiness, flavor profile, color, fat content, that is minimum fat should be around 52% etc., and the fatty acid profile, fatty acid, free fatty acids content, cell content, uniformity of bean size, insect and rodent infestation etc. So, these are the criteria for the selection of the beans for chocolate manufacturing. Then fatty acid content of the beans, in fact generally to make good quality chocolate products, the free fatty acid content of the cocoa beans should be less than 1%. If the level of FFA in sample of the bean exceeds 1%, it is likely that their level in the cocoa butter derived from them will exceed 1.75%, which is the Codex limit. So, high free fatty acid content may be due to improperly stored for a long time, that is the too hot and high moisture, high humid environment, and they are due to the activity of the bacteria or mold in the cocoa. Also, the action of enzyme like lipase etc., they may cause the breaking of the triglyceride and the free fatty acid may be generated. So, if the free fatty acid is present in the significant amounts, it may lead to the development of rancid flavor in the products. Okay. So, that should be avoided. Okay. So, there is a cut test, that is this is basically the visual examination of the bean quality, all right, is being found from the cut test. The bean cut test is used to assess the defects and the degree of fermentation. In this process, a sample of about 300 beans is randomly selected and split open longitudinally. The cut surfaces are then examined and assessed based on the fruit, flat and shrunken beans, moldy beans, salty beans, germinated beans, and degree of insect and rodent infestation. You can see here various in this the various type of the visual expression of the even color and other things are shown in the picture by the cut test. Then cleaning, breaking and winnowing operations are done to obtain the nib of consistent quality. These processes also ensure that the nibs are clean, well broken and properly decelled. The kernels, which are cotyledons, which are known as nibs, they are obtained after the process, must be of uniform size to achieve the consistent quality in the final product. So, basically that sieving, breaking and winnowing are the three major unit operations here. The sieving is done to remove all extraneous matters such as stones, strings, coins, wood, pieces, particles, nails and so on. Then it is broken, that is mainly it is to break the clean beans and to loosen the shell from the nibs using multiple steps to avoid an excess of fine particles. Finally, winnowing is done to remove the lighter broken cells or even the hulls etc. And after winnowing we get the cotyledons, that is which is nib. The breaking and winnowing steps are vital in separating the essential components of the bean, that is the nib from the cell. The cells are then discarded and they are sold for use in agricultural mulch or as a fertilizer, and the nibs are taken for further processing into chocolate and other valuable products. Okay. Then these nibs once it is obtained, it is then subjected to the sterilization process. We have discussed earlier in earlier lectures. Sterilization is the technique or exposing the beans, in this case, or nibs, to sufficiently high temperature for sufficiently long time or desired time to destroy all microorganisms in the beans. Okay, either by batch or continuous process is used, by wetting or heating steam with steams. And the requirement after the sterilization process is that the nibs should contain less than 500 total plate count or CFU per 100 gram, per gram, 500 CFU per gram, and it should contain nil pathogenic bacteria. After sterilization, the nibs can then be roasted directly using either natural process, or it can be alkalized first by the Dutch process and then roasted. Okay. So, alkalization, that is Dutch process, because this process was developed in Holland. So, it is known as Dutch process. This consists of treating the cocoa nibs with an alkali solution such as potassium or sodium carbonate. The alkali is used to raise the pH of the beans or the nibs from about 5.2 to 5.6 to near neutrality, that is 6.8 to 7.5, depending upon the strength of the alkali or nature of the alkali used. So, the purpose of this Dutching process is primarily to modify the color and flavor of cocoa powder or cocoa liquor, and also to improve the dispersibility or suspension of the cocoa solids in water, and also remove the free fatty acids present in the bean powder or in the liquor. The alkalization process can also be used to produce many different colors of cocoa powder. You can see here in the picture that is different color of cocoa powder which are produced from the alkalization process. Then important operation, that is roasting of the cocoa beans. Okay. That is the similar roasting which we studied in the last lecture in the coffee processing. Similarly, here also that the cocoa beans are roasted to develop further the original cocoa flavor that exists in the form of precursors generated during the process of fermentation and drying of the beans. So, during roasting, various physical and chemical changes take place. It loosens the shell, moisture loses from beans to about 2% final content, nibs or cotyledons become more friable and generally darken in color. There is a reduction in the number of microorganisms, degradation of amino acid takes place and proteins are partly denatured, natural reducing sugars are almost destroyed. There is a loss of volatile acids and other substances that contribute to the acidity and bitterness development. Degree of roasting may vary quite. In fact, a very light roast may be fondant roast, or high roast is coffee roast, or very light roast is coating roast, and many degree of roast may be in between. That most commonly used are full roast, low roast and intermediate roast, and in fact that type of roasting is sometimes that it's secret of the manufacturing company to have their branded flavor and branded product. So, obviously, in choosing a roast, degree of roast, attention is given to the ultimate product being made, its use and kind of beans being used. Roasting parameters depend upon the type of the roaster used and the location of the measuring instrument, that is the temperature measuring instrument put in the roaster. Roaster traditionally were of batch design, but modern manufacturing practices call more and more for the continuous roaster. There are three main methods of roasting, that is whole bean roasting, nib roasting, or even liquor roasting also. Whole bean roasting is the traditional way of producing cocoa liquor. In this process, the bean are roasted first before winnowing to facilitate the removal of the shell. Then after the roasting, next important operation is the nib grinding. Nib grinding involves milling of the cocoa nibs to form cocoa liquor or bitter chocolate or cocoa beverage, that is bitter chocolate or bitter cocoa mass. Okay. The purpose here is to produce as low a viscosity as possible to obtain a smooth cocoa powder and chocolate taste during subsequent use of the liquor. The nibs has a cellular structure containing about approximately 55% cocoa butter in solid form, which is locked within the cell. So, grinding of the nib releases the cocoa butter into liquor, that is final particle size may be up to 30 micron or so. For the production of cocoa powder, fine grinding is particularly important. Machines which are used for nib grinding may be stone mills, disc mills, pin or hammer mills, or even bead or ball mills, etc. may also be. So, actually when these are similar like a stone mill, burr mill, atta chakki, like that way similarly we are used, and then when the cocoa nibs are put there, they contain very high amount 55%. So, the heat generated during the grinding process causes the cocoa butter to melt, and in this nib to melt, and which gives a cocoa liquor, that is the melted cocoa fat carries with it the solid particles, and finally we get either cocoa mass or chocolate liquor or bitter chocolate, etc. Then these liquors is then next, as you know that these contain around 50 to 55% high valuable that fat. So, it will be wastage if this whole mass is used for chocolate manufacturing or for beverage. So, in order to make that cocoa powder for beverage industry, this is pressed, the liquor is pressed, and in fact that is a high fat cake is made of 20 to 24% residual fat in the pressed cake, or low fat cake 10 to 12% residual fat in the pressed cake. The fat in fact is partially removed from the cocoa liquor by means of hydraulic pressing, okay, applying the pressure as high as 520 kg per centimeter square, and the larger presses keep a charge up to 113.4 kg per one pressing cycle, because initially just by simple application of pressure the butter is removed, but as the quantity of fat lower down, one has to give more and more amount of pressure to remove the remaining quantity of fat, and this high pressure and high temperature develops also excessively high heat, and that adversely affects the chocolate qualities as well as the cake, the powder quality. So, in fact, it becomes this very economically unviable to lower the fat content in cocoa to less than 12%, and accordingly that there are regulations made in the industry in BISR, ISI regulations, that is it should be brought down to around 15 to 20% high fat coke or low fat cake, etc. Depending upon the pressing time and the setting of the press, the resulting cake may have a fat content between 10 to 24%. Okay, this is the limit, 20-25%. More above that, it is separated. Cocoa butter is obtained. Okay, then after the pressing, that is the cake grinding or kibbling, okay, or the cocoa powder production. These are the two major operations. That is for the powder, because this powder is used for making beverages. Okay. After pressing, the cake is released from the rather large to handle, and therefore it is passed through kibbling machines to be broken down into smaller pieces, which are known as kibbled cake. The kibbled cake obtained is stored by fat content and degree of alkalization, and may be blended before pulverization to obtain the desired type of cocoa powder with proper that is solubility and other characteristics. Then the cocoa powder, that is the grinding lines usually comprise hammer and disc or pin mills that pulverize the cocoa cake particles, kibbled cake particles into the defined levels of fineness of cocoa powder. The powder is then cooled after pulverization, so that the fat of the cocoa powder crystallizes into fat soluble form, and the free flowing powder is then passed through sieves and over magnets and packaged in bulk container and polyethylene bags. Cocoa butter is a very important product of the cocoa processing industry. You can see here it is a pale yellow color material. It has a characteristic flavor of chocolate. It is brittle at temperature below 25 degrees Celsius. It is soft in hand and it melts in mouth. It is not greasy to touch. It keeps well due to the presence of antioxidant in it. It is rich in saturated fatty acids. About 26% is the palmitic and lower saturated fatty acids. About 34% is the stearic and higher acids. 37% oleic acid and about 2% linoleic acid. Okay. And because of its melting characteristics, it becomes a very important and common ingredients in confectionery products, ice creams and such other. But the polymorphic form arrangement of the cocoa butter is very important for deciding its usefulness in the various food processes. As you can see here in the different polymorphic arrangement of the crystalline fat, okay, that is butter can crystallize into a number of polymorphic forms as a function of triglyceride and fatty acid composition influencing how the liquid fat solidifies. You can see generally 6 polyforms are produced, and these polyforms, that is they have at a 16 to 18 degrees Celsius, it is the butter that is cocoa butter is of loose capacity, and then once it crystallizes 20 to 24 degree, first polyform gamma, then during 24 to 26 degree alpha, second polyform, then beta 2 76 to 28, then fourth, fifth and finally at around 30 to 34 degree beta 1 polyform is obtained, and then this from that is alpha gamma polyform is loose, and whether other is a beta 1 is a very compact density, and obviously accordingly that is the gamma 1 is the unstable form and most stable form is the polyform 6, that is the beta 1 form. So, cocoa butter as you can see here, that is it has 6 polyforms 1 to 6, and the principal one among these are alpha, beta and beta dash. Okay. The forms 5, that is beta 2 polymorph is the most desirable form in general in well tempered chocolate, giving a glossy appearance, good snap, contraction and resistance to bloom. Then we will now come to the chocolate manufacturing. We have now cocoa powder, we have got the cocoa butter. Now this butter is made for making chocolate. Chocolate is a semi-solid suspensions of final solid particles from sugar, cocoa mass, cocoa butter and milk powder depending upon the type, making about 70% in total in a continuous fat phase mostly of the cocoa butter. That is the FSSAI guidelines gives for different types of chocolate like milk chocolate, milk covering chocolate, plain covering chocolate, white chocolate, blending chocolate, depending upon the amount of total fat percent by weight or milk fat content or acid insoluble as or milk solids. Depending upon this, various types of chocolates are made, and accordingly that is all this chocolate, that is the total fat, that is the should not be that cocoa butter of cocoa fat should not be less than 25%, and other regulations are also there in that. In the milk chocolate around 10.5% minimum by weight there should be milk solids and so on. Okay. So, the process of chocolate manufacture, technology of chocolate manufacture includes there is the mixing of the ingredient like sugar, cocoa liquor, cocoa butter, skim milk powder, etc. And all this after mixing you get agglomeration of ingredient in a thick paste, pliable thick mass is obtained at this stage, and then this mass is sent next to the for the refining, where the size reduction of the mix takes by a 2-roller refiner or 5-roller refiner. After refining, the conching is another, that is the which helps the final flavor development process. Here addition of remaining ingredient like surfactant, cocoa butter, etc. may be added, and then the conched chocolate is finally tempered, enrobed, molded or panned, and finally packaged. And in the tempering, it is in fact it gives the most stable form of cocoa butter crystal or via heating and cooling systems. So, mixing is very important. All the ingredients, that cocoa liquor, sugar, cocoa butter, milk fat and milk powder, okay, depending upon the product category, are thoroughly mixed, normally around 10 to 15 minutes at 40 to 50 degrees Celsius in the batch mixing. And the purpose, objective of the mixing is for producing a homogeneous mass which is coated properly with fat. All particles of the solid particles are uniformly properly coated with cocoa butter, cocoa fat, and also it helps the right mixing a right amount of fat. Okay. If there is a too much fat, the feed rollers of the refiner, which is the next process, will take the fat first and then later the dry solids. And if there is a too little fat, the refiner will overheat due to much friction and will produce a very non-uniform grade product. So, the mixing, maybe batch mixers can be used, or even automated kneaders are also by automatic metering of the ingredient scaling, and then properly mixing can be done. But the purpose of the mixing is to produce a homogeneous mass of uniform size. Then next step is refining. Refining of chocolate is important to the production of a smooth texture that is desirable in modern chocolate confectionery. The quality of the product depends upon the particle size distribution. A wide range of chocolate quality is produced by varying particle size of sugar and chocolate liquor. Maximum particle size of sugar may be around 25 to 57 micron, and the chocolate liquor particle size may be in the range of somewhere 50 to 114 micron. So, for a good eating chocolate, no more than 20% of the mass should have a particle size more than 22 micron. Okay. The texture of the milk chocolate appears to be improved by a bimodal distribution of particles with a small proportion having sizes up to 65 nanometer, 65 micron. The optimum particle size for dark chocolate is lower, that is at less than 35 micron, although the values are influenced by the particular product and composition. This is the refining process. You can see here that in the two roller refiner, that is this material which are after mixing, okay, they are put into the two roller refiner, and this in the two roller refiner it is a grinding of coarse particle, that is granulated sugar between between these two rollers which are here, and then they are pressed to the next roller. That is in the two roller, it increases the number of particles and decreases their size, and then these rollers, that is the next roller, moves at a larger speed than the previous roller. Okay. So, this wipes the material and carries sent to the next roller. Okay. That is then, and in fact the clearance between these roller has to be adjusted by the operator depending upon the size of the particles which is to be obtained finally. Okay. So, this second, third roller, fourth roller, etc., they reduces the size of the chocolate particles, so that they cannot be detected even by the tongue. You get a completely homogeneous mass, it gives a smooth taste. And then finally, in the last roller, it is taken out, the particle size may be of 20 to 35 micron. The components of the different 5 roll refiner are shown here. It consists of roll stock pressor, chocolate film, chocolate feed roll pressor, fixed roll, chocolate from scraper, and motion of the rollers. These are the various accessories that are provided in the refiner. Then conching, very important operation. You can see here in the figure, it is regarded as the end point or final operation in the manufacture of bulk chocolate making. Conching is basically a balance of the temperature, time, agitation and aeration. Dry conching is utilized when the feed material to the conch cannot be pumped. Heat generated by the agitation must be dissipated either by atmospheric conditions or by water jacketing equipment. Wet conching utilized when the feed material can be pumped to the conch, and in this case heat is supplied by the hot water to the jacket to the conch. Okay. The different phases you can see here in the conching process. Okay. The longitudinal conchage has been traditionally used in the industry, but now rotary conchage are becoming more popular as they can handle large quantities of chocolate and require much less labor. Both the milk and dark chocolates are conched at around 49 to 82 degree Celsius for about 1 to 4 days. Okay. You can see here the internal mechanics for Fisher conch, which is a rotary concher. That is, the Fisher's conch is an overhead conch used in the modern chocolate industry. It has a large tank, bigger tank with 3 powerful intermeshing mixer blades providing searing and mixing action. So, during conching the chocolate flavor develops, its color darkens, it stabilizes the viscosity by covering all interfaces with cocoa butter, and there is some lowering of moisture content. The flavor development results from mainly volatilizing the undesirable flavor, as you can see acidic material etc., that they get volatilized. Okay. Some moisture also goes out. Okay. pH increases as the conching proceeds, and oxidation and browning reactions in the milk type chocolates also take place, which add to the flavor, color and flavor. Okay. Then finally, the tempering is process, that is, the tempering involves pre-crystallization of a small portion of triglyceride with crystals forming nuclei, maybe 1 to 3% total, for the remaining lipid to set in the correct form. Tempering has 4 key steps, as you can see here in this figure. All right, that is, the first is the complete melting at around 50 degrees Celsius, then cooling to the point of crystallization, material is brought its temperature to around 32 degrees Celsius, then crystallization occurs at a temperature of 27 degrees Celsius, and finally conversion of any unstable crystals at 29 to 31 degrees Celsius. So, here in the figure, that is a tempering sequence during lipid crystallization of chocolate is shown, that is the solid chocolate, then the temperature 50, all fats melted, then correct number of stable crystals you get at around 27 degrees Celsius, and finally temperature is little bit raised, any unstable crystals are melted out. Okay. So, a well tempered chocolate have the properties like it has good shape, color, gloss, contraction from the mold, it has a better weight control, stable product, harder and more heat resistant, fewer fine grades during packaging, and with a longer shelf life. For chocolate to be an appropriate polymorphic form, tempering is crucial, influencing final quality characteristics such as color, hardness, handling, finish and shelf life. Okay. In fact, multi-stage heat exchangers are used for tempering of chocolate. Then finally, the casting and molding, you can see here in the figure, casting, molding and finally molded chocolate, that is giving the chocolate the desired shape. The tempered chocolate enters into the hopper of depositor, which deposit chocolates into the molds of different sizes. The rheological properties of the molten chocolates are critical to obtaining uniform weight and size of the finished product. A vibrator shaker shakes each mold to the level of the liquid chocolate deposited in the mold, and then the molds containing the molten chocolates after vibration pass through the freezing section, and they are cooled in a tunnel freezer at around temperature of 12 to 15 degrees Celsius. In the batch processing, the molds are cooled in a refrigerator at around maybe maintained at around 7 to 10 degrees Celsius for 20 to 30 minutes. a small amount of force is needed to part the product from the mold, and this is affected by a hammer aided by mechanism that twists the molds. Okay. And finally, these products are again packaged in laminates or metallized polyester under controlled environment. Okay. And the packaging material should have proper characteristics, appropriate characteristics, particularly hygroscopicity, gas permeation or oxygen permeability, that is it should be impermeable to all the light, gas, oxygen, etc. so that the color and flavor and characteristic texture of the chocolate is maintained during packaging and storage. So, finally, I will summarize this lecture that as cocoa beans, once they are obtained from the trees, okay, then they are fermented, left open for some days, then after that they are split open, fermented, and the unwanted seeds, pulps, etc. they are removed, and the cocoa beans, which is that is means of the industry, they store these cocoa beans, that when maybe for years together it contains 10 to 12% of moisture content, and then these cocoa beans and desired, this is further roasted, and then it is grinded, and during the grinding heat produces that is melts, causes the melting of the butter or fat, then melted fat carried with it the solvent to get the cocoa mass or bitter chocolate, and this is pressed, butter is obtained, and the cocoa powder is prepared. The cocoa butter is mixed with their appropriate amount of milk sugars, that is the milk solids, sugar, etc., and other flavorings and other agents, and it is converted into the chocolate. And chocolate manufacturing basically consists three major operations like mixing, refining, and then finally conching and tempering, and then properly tempered cocoa butter or chocolate is then molded and packaged, given the desired shape and packaged. So, these are the references which are used in this lecture. Finally, thank you for your patience hearing.